Hey, what's up guys? Welcome to this next lesson of C++ in 2021. We're going to take a slightly different gear this time, and we're going to start looking at threads and concurrency in C++ today. We're going to start off simple because I have less time this week for a video, and secondly because it can get complicated quickly, and I want to make sure I truly grasp everything and give you practical examples of how to do everything. So what we're going to do today is we're actually going to build a very basic, let's say, task queue, where you can give your task queue, we're going to call it TaskManager. So you can give your TaskManager commands and it will queue them up and run them on a separate thread for executing in parallel with the rest of your application. Let's just jump into it now, and we'll try to do this in a fairly straightforward way that you can understand. So again, if you want to hear more, if there's anything that I don't go over that you would like me to focus on next time, leave a comment down below, hit like, subscribe, all that crap, and let's get into it. Alright, so I didn't mention it last time, but you can find all the source code for all of these tutorials on gotta push the tags, but you can find all the tutorials on my GitHub, github.com/mobiletechnologies. In CPP in 2021, you'll have all of the new code here. So current code is all the input manager code from last time. So go there, you'll have the newest stuff there as well. I'll push the tags soon. I have the tags made locally, but for some reason I didn't push them yet. Okay, so let's do our task manager. So the first thing we're going to do is, this is not properly organized for a real project, but we're not going to worry about that too much now. We'll call this tasks. And in here we are going to create a new module, and we're going to call this C module task manager taskmanager.ixx. And we are going to also make a taskmanager.cpp as well. Taskmanager.cpp. So here we've already got our module exported here in our task manager CPP. We're just going to put module task manager, and we've got our everything set up. So what we want to do is, when we run our program, we want, during the runtime of our application, we want to be able to dispatch tasks to our task manager to be run concurrently with our application. Now we're going to be doing it in a very naive way. There's going to be one thread. It's going to always be running, so it's not going to be very efficient. You're going to want to probably put some sleeps in there or something, but we'll get to that as we move forward. So let's start building stuff out. So the first thing we need to actually define our task manager. So we're going to export our struct task manager, and that's going to be the basics. Now we're going to put a private field in here, public field. We'll need another private field, and I think that's everything we'll need. So what do we want to do with our task manager? We're going to want to be able to create it, which we'll just have a bunch of default constructors for all of our fields, so we don't need an explicit default constructor, but let's put it in there just to be explicit. Let's do that. We're going to need a destructor. We'll see why in a bit, but we're going to need a destructor. We are going to need to be able to start our task manager. So this is going to be, we're going to give it a start function. We're going to need to be able to queue up commands. So let's say void queue command. And what we're going to do here is we're actually going to do export. I think I can do this. Let's try export using command equal int. Is that? Yeah. And queue command is we're gonna put a command in here like this. So our commands themselves are just going to be integers, but we're just going to call it command to be explicit. I think that's everything we're going to need for now as part of our interface. There's going to be one more thing, but we'll add that when we need to. So we've got our interface. Let's go into our main.cpp and implement it, right? So first we are going to import our TaskManager. And how are we going to do this? So the first thing, we've got to add our TaskManager to the bottom. So TaskManager, and we'll default construct it. And we are also going to introduce our, let's call it game loop, which requires a Boolean running variable. And this one will be initialized to false. So in our run function here, we are going to say while running here, and then we'll just add some log messages so we can see things happening. Game loop ended, and do that. And one last thing, at the beginning of our run function, we are going to set running to true. So when we call run, it'll set running to true, and while it's running, it will run the game loop. So this is just so that we don't just run. So we notice here we call run and then we exit immediately. This will just make it so we don't exit immediately. We keep on running. So when we call run, what we are going to need to do, what we're going to need to do is when we call run, running is equal to true, and we are going to start our task manager. Now this is just at the beginning of our application, we'll start the task manager. We can actually start it whenever, but this is when we're going to start it. Then in our running loop, what we're going to do is we're going to take input. We're going to take an integer. We're going to assume they're always going to give an integer. And then we are going to send that command to the task manager. So what we're going to do is we're going to do int, we'll say command number, let's call it command 0. And let's just make sure that builds to make sure that I can export the using. Okay, so this we'll deal with that after. It's complaining that this stuff isn't defined yet, so we'll go back to it in a second. So command 0, and then what we're going to do is we're going to say std count. Give me a command. Must be an integer. And we'll give that a new line. Then we will take in the thing into our command, and we are going to just print out which command we got. You gave me, oops, we will use std format. You gave me command there, and we are going to give it command. And we are just going to give it an exit case. So we're going to say switch command, and if case is -99, this is going to be our exit case. We're going to set running equal to false and break that. So in theory now, we should be able to, this should start a loop. It will ask for input, and then if we give it -99, it'll quit and it'll say game loop ended. So let's solve these IntelliSense errors before we can build. So we need to define all of these functions here. So we'll create a definition here, and it's creating them all in a bad spot, but we can copy paste them in a minute. We build them here. So this is C++ module 20 stuff that hasn't quite figured out its code generation yet, but we can do that. Now let's try building this and see what that gives us. And that builds properly, so we should be able to do this. All right, so let's say we give it 0, and we give it 2, and if we give it -99, game loop ended, and it closes gracefully. And that does exactly what we wanted to do. That's good. So what we're going to do now is we are going to give it a default case. So anything that is not an explicit command, we are just going to pass it into our task manager. TaskManager.q command, right? And here we should give it command here, Q command, good. So start, we're going to do a few things here. Now we will take this and we will put this inside our Q command. We're going to say queuing command, queuing command, and we will import format. And import IO stream. All right. And now we should be able to build this. It should run, I believe. Yes, it runs. We'll play this, and now if we give it here, it'll queue the different commands like this. There we go. So we've got the basics going on. We've got it so that we've got a task manager and we can run Q command through it, and we will put another thing here. Std. No, we don't need a std format here. Task manager starting. All right, and we'll do this. So is there anything missing here? We've got the task manager start, task manager Q command, and we have a way to exit. So we've got everything in place for our basic task manager, right? So what we're going to do now is we're going to add a thread to it, and we're going to start queuing commands. All of the stuff that we're going to need for threading is going to be stored inside the standard library thread header. That's all we're going to be using for today that's related to threads. And the object type that we are interested in storing is going to be std thread, and we'll call it command thread. So with our std thread defined here, what we can now do is start the thread when we call the start function. So how do we do that? The basic syntax of starting a thread goes like this. So let's go into our main.cpp. No, I'll do it like this. So let's say we define just a basic global scoped function here. Let's say void my function, and we put here while for int I equals 0, I smaller than 100. Let's put I plus plus std count std format. All right, and let's put a new line here. Let's not put a new line, who cares? All right, so we have a function here that just prints out 10,000. Let's make it 100, 1 million. Let's say 1 million eyes, and let's put a space in between them. So we print out 1 million eyes, million numbers, and we want that to run in the background for whatever reason. Let's ignore the Q command for now, and let's just say while we call start. So if we want to call this function from a thread, what we would do is, let's say we do command thread equals, and we call the constructor of thread with the function itself, the function pointer, or the name of the function, like this. And this would start the thread. That's all you need to do to start a thread using the standard functions. So let's assume that, let's put this up here. Let's do that at first, and we call start, and then let's say while running, we will say we're going to actually, this is going to break some stuff. We're going to see some errors, but we'll do this for now just to show you what it does. Std count game loop, and we are just going to pad this with spaces. Right. So in theory, what we should see is we should see this get called. It will start the thread. It will run this 1 million times, and in between this, you should see that this loop is running at the same time and not waiting for all this stuff to happen. So let's see what happens when we press play. All right, so let's wait for this to stop, and you'll see that the numbers and the game loop is interspersed with each other. Here, let's stop it. It's going to take a while because printing takes. But you see here, they're running concurrently, or they're sharing time. So you hear it seems pretty one-to-one. Game loop this, game loop that, game loop that. But here you see a bunch of numbers in a row, and then game loop. So it's not necessarily one at a time. Let's close that. And if you control C out when there's the thread running and you don't do it gracefully, you're going to get a compiler error. And it's going to just basically tell you that you had a kernel panic or some crap. But ignore that, it was expected. But you saw the output there where the game loop words were being printed, were competing for processor time with the printing of this my function. Right? So what do we want to do to be able to, let's say, for example, we wanted to wait until this was done before returning from this function, right? So when you create a thread like this, it is said to become joinable, meaning that you can wait for it, or that you have access to the thread. So you could do, what you would usually do is you would put like an if function and say if command thread dot joinable. So what joinable is means that the thread is both running, currently running, and it is and you can block on it. You would do something like you would then do command thread dot join. And what join does is join waits for this function to return, or the function that you created that is running in the thread to return, and join with the calling thread, that's why it's called join, before continuing on to this function. So let's just say std count finished joining, right? Now let's put a new line here. Let's make this smaller because we don't want to have to go over that many every single time. And if we go to main now, you'll see that game loop doesn't show up until TaskManager start is finished. So let's go into that now. All right, stop. All right. Let's go back into here, and hopefully we still have so you see here it printed all the numbers, called finish joining, and then went into the game loop. So that's probably the one thing you need to get a grasp on the most, is knowing how to properly join your threads and how to keep track of them properly. Now that's not what we want for our implementation. Ideally, our implementation, we want to be able to add, we want to be able to call stuff on the TaskManager stuff, add stuff to the queue, and have the thread pull from the queue and execute the commands. So you're not able to do, for example, like this dot run. You can't do that, right? We will need a run function. So let's create that run function now. Let's go inside here. We will go. This can be a private function, so we'll do void run. Help if I did that. All right, good. And now let's create the definition, and that did it in here properly. All right, so we got void run. So what void run is going to do is we are going to move this here, and we're going to add some std counts here. We're going to say thread starting, and thread shutting down. And this is just for demonstration purposes. So we want to be able to call this run function like this. And we don't want to call my function. Let's get rid of this now. So what do we want to do? So the std thread has an overloaded constructor, which takes, similar to the function bind syntax that I think I went over last in the function pointer video, but it's similar to function pointer syntax, where you would do end, then class name, TaskManager, function name, run, and then the object that you're binding to. So in this case, it would be this. And what this will do is it will create a thread that runs this run function. And again, we can just call this, and this should show off what we're looking for. And let's get rid of game loop. So you'll see here when we run it, thread starting, thread shutting down, finish joining. And that's exactly what we were expecting to see, right? So it created the thread, it ran the function in the thread, and then it waited for it to be finished. And once it finished, it exited out of everything. So that's all we need in our start function. But what we want to do is we just want to make sure that we don't, when we call start, we don't override any existing running thread. So we're just going to put this here. We're going to put this at the top. So if it's joinable, it means that it's already running. We are going to print a count statement just for our records, and we'll say thread TaskManager already running. Do that, and we can return out of this function. And this will just prevent us from overriding the thread. And we don't need to keep this either. All right, so when we call start, it's going to run the thread, and it's going to call run. So let's define our run function now. So our run function is going to be relatively simple. So the first thing we're going to do, we're just going to say running equal true, which I believe we haven't defined yet. So we can go here, and we're going to need another bool running variable, and we'll initialize this as false. Then we will say while running, like this. And this is going to be pretty much our entire loop. And what we're going to need to do is we're going to need to define a way to turn off running, right? So let's, at the top here, we're just going to do things in a dirty way. So when you're using modules, you can use this module keyword with just a semicolon with no thing. And you can put any defines you need here, or any includes as well. Any old hash pragma functions you would put here. Now we're just going to do this for simplicity, right? So let's just say we say exit. We'll say exit thread is going to be -1, and we'll say define. We could have done this as an enumerator as well, but we're going to do it this way just for simplicity, I guess. And let's just say print bananas is going to be our second command, and that's going to be command 1. So these are going to be the commands we support for now. Like I said, it should be an enumerator, ideally, or in something a little bit better than just defines and integers, but that's not the purpose of this lesson. What we're going to do in while running is we are going to maintain a queue. We're going to pull from a queue, and then we are going to execute the next command in the queue, and it's always going to be first in, first out. So we're going to implement a FIFO queue that executes in a thread. So what we're going to do is we're going to import the queue, which is going to be dq, I believe, like that. And then we're going to create the queue here. Instead, dq command q, and that we can give a default constructor. Right. So when we restart our command queue, we're also going to our command thread. We're also going to clear our command queue, so that we just know that if we are restarting a queue, we should flush the queue just to make sure that there's no old commands inside. And what we're going to do in here is if the queue is empty, we are going to just continue. If command queue dot size equal 0, continue. We'll do that. Otherwise, we are going to execute the command. So we're going to our DQ here will be commands, like that. So we are going to execute command, which we haven't implemented yet, but we'll get that in a second. Command Q dot front. So we'll get the thing at the front of the queue, and then we are going to pop it after, and we will pop it off the front of the queue once we're done executing it. So that makes sense. That's pretty much our entire thread loop here, but we just don't have our execute command function. So let's implement that, and this is going to be fairly simple as well. So it's going to be another private function called void execute command. It's going to take a command, and let's implement that. Let's just wait for, let's not wait for IntelliSense to catch up, because clearly it's having issues. So I'll just do it like this, and we're going to say execute command. All right. So to execute our command, what we're going to do is we're just simply going to put a switch statement inside here. Switch command case exit thread, break here, and case print bananas, and we'll put another break here. All right, and I think that's, yes, that should do it. That should do it. Now let's just make sure it builds and see what happens. And it all builds fine, so we're good. All right, so now that it's all built, let's finish writing this. So exit thread is going to be simple. We're just going to call running equal false here. And what that's going to do is it's going to execute the command, and it's going to say running equal false, and then it's going to fall out of the function. Now, it might be worthwhile putting a while loop here and making it not equal 0. That will make sure that the entire queue gets executed before it exits. But I would imagine if we're doing a FIFO and exit comes before commands, it should not execute any commands after a request to exit. So let's assume that's fine, and print bananas, we're just going to say bananas and give it a new line. All right, so that's most of our queuing task manager complete. So when the thread is run, when we call start, it's going to check if the thread is already running. If it's already running, it's just going to do nothing. It's going to be a no-op. But if it's not running, it's going to clear the command queue, and it's going to run the call. It's going to start a new thread with the run function running on its own thread, which is here. Then the run function is going to run a while loop that's going to run until we call the exit thread command. That's pretty simple. Now, there's going to be some problems with this, but we'll get to that and more a little bit later in this lesson, and then we're going to go more in depth in future lessons as well. So, what's left to do is to implement our queue command function. What we need to do is do if not running. So if it's not running, we are going to print a message, std out TaskManager is shut down. Please call start again to begin queue. And call that, and then we are going to return from here. And then we'll move this down here. And then this one, simply after we check to make sure it's running, we just call a command queue dot push back command. like that. So we have everything that we technically need to run our thread. So let's run that now. So what do we have here? So let's uncomment this stuff. And in theory, this should work, right? Yes. Now there's going to be an issue if we call -99 now, but that's one of the things I want to show you. So let's do this. Now thread starting, now we give it a command. So if we give it anything other than, let's say we give it 0, you'll see here now it's queuing the command. If we give it 8, doing that, but if we give it 1, it prints bananas, right? And if we give it -1, thread shutting down. And if we give it try to print bananas now, it tells you that the task manager is shut down and we need to call start again. So that's pretty much everything. But now let's say we want to quit the application with our -99. You see we get an error. Now what this error is basically you've shut down the application, or you're trying to shut down the application, but you still have a thread running in the background. You don't know if that thread has been cleaned up properly, or if there's data that needs to be saved out before it quits and all of that. That's one of the things you need to take care of. It's one of the reasons that we created a destructor up here. So it's actually fairly simple. So I showed you the join command before, right? Which basically says that it's going to wait for a thread to finish before continuing on in the function. So, and you need to call that, the join function, from the original thread that, created the thread that is shutting down, that you're joining. So to make it a little bit clear, when you run main, this is going to be on one thread. Your main function here is going to be on one thread. When we get here and we call start, we're creating another thread. And when we get to the destructor of TaskManager, that is actually going to call the destructor on the main thread as part of the stack unwinding process. So what we need to do now is to, in our destructor, ensure that we wait for the thread to be complete before we continue. So we'll say running equal false. This will force shut down this loop here, which will shut down the thread. Then we will check to see if it's joinable. If the command thread is joinable. So what this will, not is joinable, just joinable. So what this will do is that if the thread is still running, it will fall into this if statement. If the thread was previously stopped, it will actually just skip it altogether and everything will work fine. And we'll do command thread dot join. And what this will do is it will wait for the command thread to finish. So if you've got a command in flight, so you've called execute command, we got some really expensive database command in here and it's saving stuff out, it's going to finish and fall out of this while loop before finishing the destructor, which will give it time to clean up gracefully. And that should be everything we need to fix our -99 problem here. So let's start that again, right? And let's say thread starting, give me a command, -99. And there we go, no errors. That is precisely what we want. Now, I am mildly confused, so let's do this. Let's comment this out and go back here. Now I'm mildly confused because if we go to, we say -1, that shuts down the thread, right? But then if we do -99 now, we still get an error even though the thread is already shut down. So let's just say here, still joinable. -1 shuts it down, -99. So that's odd. So if the thread exits normally, you still need to call join on it to properly shut down the thread to clear its resources. It won't just clean itself up. It's good to know. That's good to know, because it means that this is really important. So now you can probably do this. Put the running equal false in here, then, and close this. Right, and start thread.joinable, and exit thread running equal false. So what this needs to do then, so if running equal false, then if not running, then we should command thread.join, and then we're just going, we're learning together here. Thread finished but wasn't joined, joining to clean up. And then else, one of the rare times you'll see me use an else statement. There we go. So now it'll check to see if it's joinable. If it's joinable and it's not running, then it means that it should be, that it's already been shut down, but it wasn't cleaned up properly. It had never joined. If it's running, then it's already running. We shouldn't do anything. So that makes sense. Now we can implement a restart command inside here. So let's say case 98, and this will be restart TaskManager, and we're going to say TaskManager dot start, and we'll call break here. Okay, so let's try that and see what we get. Alright, so if I call -1 now, and then we call -98, yeah, we have thread finished but wasn't joined, joining to clean up, and then we start the thread. That's exactly what we want. And then we can give it more commands like bananas. And then we say -1, shut it down. We call 1, TaskManager shut down. Excellent. That's perfectly what we want. TaskManager, alright, so doing Control-C will always give you an error, and that's, you need to implement a signal interrupt to fix that, so we're going to ignore that for now. Let's just assume that we always shut down gracefully with our -99 here. So let's go here, and here we have while running is true, Q command, this is using running. Okay, so that's what we have here. We have a task manager which we can queue commands in. So here, let's create one more command, and this is going to, let's say, define print a bunch of numbers and we'll make that command 2. And we'll put that case inside here, print a bunch of numbers, and for int I equals 0, I smaller than 1000, I plus plus, std count numbers I. Alright, let's do it like that. I should have used std format, but this is easier to remember how to do. Easier to do. So now we can send it a command 2, I believe was what I gave it. And that'll start printing a bunch of numbers, and we can print bananas in the middle, I believe. So let's see what happens. Thread starting. So let's say we go 2 and 2. 1, 2, 1. Now let's see what happened there. So you see here we have queuing command 1. So it queued a command mid command, and then at the end it called bananas, right? So let's make this bigger. Let's make it 10,000, and let's say 2 1 1 1 1 1 1 1 1. So it's going to print 10,000 numbers like this, and then at the end it's going to print all the bananas that I queued. That's precisely what we wanted. So let's say minus 99, shut down the thread, game loop ending, exactly what we want. So I believe that's pretty much the basics of using threads. Now there are a lot of things that can go wrong here, like I said. So in general, when you have an object that's using a thread like this, that's maintaining its own thread or thread pool, you always want to make sure that you're clearing the joining the threads in the destructor. So it's resource acquisition is initialization or whatever RAII pattern is a good way to go about it. You want to make sure that just like files, when you call open, you want to call close. If you're using a thread that you're maintaining control of, you will always want to call join. Now, one thing you can do, if none of this matters to you, if you don't need a handle to command thread, you can have as many of them running as you want. There's one command you can make I call thread detach. Now you can only call detach on a thread that is joinable. So to get around this issue here, what we might be able to do, and let's just see if it'll let us do this, it might not. What you might be able to do is in our run command, if we do here, we might be able to do command thread dot detach. Now let's see what happens. This may or may not work. So let's call -1 there, and now if we call start again, which I believe was 98, before when we called start it would be joinable, so it would join the cleanup, right? But now if we call -98, you see it just starts the thread without worrying about whether or not it had already been joined, which is actually an improvement. So that gets rid of this if statement, and we can close that. So basically what this does is once the thread completes at the end here, oops, let's close this, -1, nope, -99, there we go. All right, so once we do this, what this will do is make it so that once the thread is closed, we don't have to worry about it. So we can actually just do run equal false, and we can probably get rid of this, and it should probably give us the same result now without giving us our errors. So -1, shut down, we give it -98, it starts up, and if we say -99, we get our error. So that didn't fix the error because it goes too quickly. So this is useful for starting and restarting and stopping your service, but not so much if you need to clean it up at the end. So yeah, I would recommend keeping your joinable join commands here just to be safe. Even though I think this might actually throw an error. Let's see what happens here. It started -99. Yeah, so this throws an error because it never you can never join after calling detach. So what if we do it like this? I'm just playing around now to see, and we get a different error. So we can probably do thread.detach. Will that work? And this is going to give a race condition. Oh, well, it worked. So I guess you can call, what happens if you call detach twice on a thread like this? So let's do -1, it gives an error. So we will do if command thread.joinable, and we will detach the thread. Okay. So this puts in a couple guards, and this is clearly probably not the kind of thing you would want to do. Doing it both inside your run command and inside here, calling detach in two different places, it's probably not a good idea. The best idea is probably, so maybe this is okay for now. Yeah, we'll do it like this. And actually this is the same code basically. So what we could do really is create a shutdown method here. Shutdown. Let's define our shutdown method here. We are going to do this and put this inside here, and then we are actually just going to call shutdown here. Shutdown, and we are going to call shutdown up here as well. Now in theory that should remove the need to take this out because it'll detach as soon as we call shutdown, and I believe that that's going to solve our issue. So let's go -1. That worked fine. -99. That worked okay. Let's do the other way around. -99 and no error. So that's the better way of doing it. So our shutdown will check to see if the thread is still joinable. If it's joinable, we're going to kill the thread and detach it just so that we don't throw any errors on exit, because we know that it's going to naturally run its course throughout. Now, again, without ranting too much more, this probably won't scale. Once we get the thread pools and stuff, we're going to get a little bit more complicated. But this is just to show you a general idea of how you're going to start working with threads, the different things you need to think of when working with threads, making sure that everything closes properly, like a file. Like if you have an open, you need to close in a file. If you open a thread, in general, you need to either join or detach your thread. And it shows a general queuing system as well. So let's show off the queue one more time. So we're gonna queue that, and we're going to put a whole bunch of bananas. Now I'm just building a whole bunch of queues there, and you see here it printed bananas the whole amount of time on that queue without interrupting the process of printing out everything on that queue. So what this does is it allows us to take input from one area and then use that input to affect a process somewhere else. So you'll see this with input. As I said, web servers use a lot of threading. Render loops in game engines will often have their own thread, or at least how they build their render commands will often be threaded. Physics will usually be on its own thread. So knowing how to use threads is very important in the modern day. So that's why we're going through it. Anyways, I think that is good for now. We don't need any more context for now. We are very early on into this book, C++ Concurrency in Action. So if you'd like to get to the next topic on threading earlier, let me know. Otherwise, we'll see. I don't know what I'm going to be doing on the next one. I'm kind of jumping around as I want to gain more knowledge or gain more practice myself through different things. So this was a fun experiment to build a little TaskManager system. When we get to thread pools, that's going to be even more interesting, and trying to scale your number of threads based on your hardware, that's going to be another thing we're going to look into at some point, and a bunch of cool things like that. So again, leave a like, subscribe, all that crap. Comment down below with what you like. It seems like I'm getting to 1,000 subscribers fairly soon, so there's going to be a deviation from my standard tutorial content for a 1,000 subscriber special. So if you want to see that happen earlier rather than later, hit that subscribe button, because it'd be cool. Anyways, see you.